Welcome, I'm Sébastien Lacoste. This is Nicolas Fischbach. We are working for Colt Telecom, a large ISP in Europe. So we are working in Switzerland. So the topic today will be layer 2 routing protocols and a few hints and topics on router security and forensics. So on the layer 2 side, we will talk about most of the layer 2 protocols you are used to see out there in the world. It doesn't work. This screen doesn't work. No, it doesn't work then. Sorry. So I will present ARP, SDP, CDP, DPT, and also VLAN and HSRP, VRP. So the goal will be to show you what can be done with those different protocols and how you could protect against the different attacks we will present. And then Nico will take over and will talk general configuration information based on Cisco equipment. And we'll have a presentation about how you can do a router forensic and integrity checking for your Cisco equipment. Okay, so the layer 2 protocol attacks are already used. Some are well known. So most of the attacks already used are IRP-based attack, like cache poisoning. You have a set of tools available for those attacks, like DSNIF and Taranis, IRPOC, and so on. So people are used to those attacks, but you can do much more on your Ethernet-based network. Mainly on new protocols or protocol used for high availability like HSRP and VRP. There are also a lot of bunch of attacks you can manage against VLANs and spanning tree protocols. What we will see in the future, there are more and more people investigating this area, doing some research, and there are more and more tools available. And most of the time, the network crew is not used to have a look at this layer of the network. So the main issue is that, if someone managed to do or to attack you at those layers, nobody will notice it. Yeah, and this small hint, Nico will talk more in detail later on. We are seeing more and more research on rootkit and for embedded device of our network equipment. So I don't know if you attended the FX talk earlier. He presented some nice stuff against the IP printer and Cisco devices, and there are much more coming, so be prepared. Okay, I already presented quickly the different protocol I will go through. So let's start with spanning tree. Spanning tree is, probably everybody is using it, even if you don't know about it. It's used to prevent loop in your Ethernet network. So mainly this protocol will detect loop in the network and block the ports to prevent the loop to happen. So on most of the switching equipment, spanning tree protocol is enabled by default on all ports. And what you have to do is spanning tree protocol doesn't was not designed for security, so you have no way to not a lot of different way to protect against spanning tree attacks. So there is a small state machine presenting the spanning tree processing for a Cisco router. So what has to be done, as long on a Cisco at least, as long as spanning tree is processed, the port will be blocked, so no traffic will be received or sent over this port, which can be used later on for denial of service attack. So how the spanning tree usually works, so this is a sample network with like 4 switches and a redundant link on the 2 upper switches. So spanning tree will elect a root switch that will be the master for the spanning tree processing. And the spanning tree protocol will run and will block the redundant links to avoid loops on the network. So basically all the traffic will go through the root switch. So this is nice to know. If you are now on a network with several switches and you want to do some traffic interception or sniffing, this could be used. You could use spanning tree to force the traffic to go through you. So here is our attacker connecting to the two switches. So for this kind of attack, you need to have access to two different equipment, two switches. So what you will have to do is pretend to be the root switch. So it's an election process. So the only thing you have to do is to announce yourself with the higher priorities than the existing switches, and then run spanning tree and force the blocking of all the other ports. So doing this, all the traffic between the right and the left side will go through the attacker. So then you can freely sniff the traffic, and mainly nobody on the network will notice it because it's totally transparent, and most of the time nobody is monitoring this layer of the network. So yeah, this is quite nice. And other kind of spanning tree attack you can do is one which is more well known is CAM, MAC address entry poisoning. So you can have a DDoS, denial of service against the switch doing that. What you could also do is force infinite spanning tree processing, meaning during the processing all the ports are blocked. You will have a completely denial of service on your Ethernet network. So those attacks are pretty simple to make. Spanning tree protocol is not really easy. You have several implementation, like in the Linux kernel, for example. You have patch for it, and you have a set of tools for manipulating spanning tree. So it's really easy to make and really hard to track down, because once spanning tree is running, you don't have any more access to your equipment. So what you will need is serial access to all your switches, analyze the spanning tree topology and see and try to understand what's going on. So there are a few security measures you can use as a prevention against those kind of attacks. The main one will be to monitor which equipment is a root bridge. On a stable network, if you don't add or modify the configuration of your equipment, the root bridge shouldn't change. So it should be always the same equipment. And if you have a large network, usually you define yourself which one is a root bridge by setting up a higher priority for this one. Another thing you can do is filter MAC address that can be available on each port. So depending on your equipment, you have a different command set. Here we are presenting the command for Cisco switches. So you can just define which MAC address are available on a port to avoid someone plugging in on your network. Now to filter a spanning tree attack, what you should do on each port which is not connected to another switch running spanning tree, you should disable spanning tree frame, PDU protocol. So here you have as example the command line for a multi-layer switch. So it's pretty simple, and you can deactivate it for the whole switch or per interface. Just a small note, there is a nice feature on the Cisco switches. You can filter the amount of broadcast traffic allowed on your network. So it's just a percentage of your global traffic, and it's also very convenient to block broadcast storm and so on. So now we move to another protocol which is used by Cisco. So it's a proprietary protocol. So it's based on HDLC. This means it doesn't use IP. It's a multicast traffic. So basically CDP is used to automatically discover your network. Every equipment will broadcast a CDP information which contains device name, network, configuration, capabilities of the equipment, and so on. Okay, so this is an example of a capture CDP packet. So this was in a previous conference in CanSec West in Vancouver. It was on the hotel network. So this was the main router of the network. So mainly what you will be able to see with CDP was the IP address of the management network, which is the first red circle. So which is quite convenient if you want to attack it. And you can also identify easily the model of equipment. So if you have an attack for a specific model of equipment, This is a way to identify the equipment very easily. You have also to know that spanning tree is subject to denial of service attacks. It was discovered by FX last year. So you are able to just send a lot of CDP packets to the router or to the equipment, and it will just crash when the CDP entries memory will be was full. So the security measure, usually you don't need CDP. You have probably other monitoring tools that don't use CDP, so if you don't use it, just deactivate it. It's just simple sanity measure. So you can deactivate CDP for the whole equipment or on each interface of your equipment. So you have the example of configuration. Now we move a little bit to the VLAN, so layer 2 partitioning. So as you probably all know, VLANs were not designed for doing any security. It was just for network isolation, just for easier management or administration. Unfortunately, a lot of people tend to use VLAN to partition network. So as this protocol was not designed for security, you have a few flaws or at least a few points you should pay attention to. One main protocol which is used by Cisco, which is VMPS, which is a VLAN management policy server. It's a very nice protocol. You on the VMPS server, you just define a MAC address of your workstation, and you define on the server which in which VLAN this MAC address will belong to. So when you want to use your workstation, you just plug on any switch, and you will automatically belong to the right VLAN. So the problem, it's easy to spoof the MAC address, so if anybody knows your MAC address, they will have access to your VLAN. So yeah, just do use this protocol. That's cheat. Another problem with VLAN will be to be able to jump across VLAN. So in the past, there were several issues with the switches when you were able to break the switch by jumping from one VLAN to another. In the latest release on most of the equipment, it's impossible or much harder to do. However, there are some protocols used for VLAN management, so like DTP, which is Dynamic Trunking Protocol. So DTP is used to send several VLAN bits across switches. So typically on one port, you will have all the VLAN going through this port. One main problem is that on a lot of equipment, all the ports are able to do DTP by default. So you just have to plug to the equipment, say, okay, hello, I want to do some trunking. So the switch will say, okay, fine, let's do trunking. And then you will have access to all the VLAN on the switch. So you will just have the choice, you will be able to choose on which VLAN you want to send your packets, and well, it's done. Yeah, mainly. So main protection against DTP is just deactivate it on each port which doesn't need to run trunking. So by default, only the port between switches which are in trunking mode should be allowed to use DTP. Another nice protocol is VTP, which is a VLAN trunking protocol. It's a protocol used for centrally manage all the VLAN. So with this protocol, you will be able to, instead of going to each equipment and define which VLAN are available on your network, you will only need to go to one equipment, define the VLAN, and it will be spread across your whole network. So it uses CDP-like frames, and it communicates only over trunk ports. So using this protocol, you can easily add, remove VLANs, or create spanning tree loops in your network. So definitely, you should deactivate it, or at least set a password on it. So you have an example of command for Cisco switches. Okay, coming back to the DTP. So as I said, with TP you can inject frames in any VLAN you want or jump between VLAN. So deactivate it if you don't need it. Okay, another protocol which is often running if you have high availability or equipment, it's HSRP and VRP. So HSRP is used mainly by Cisco, and VRP is a more standard protocol used by like Nokia, Checkpoint Firewall 1, and so on. The goal of those protocols is to provide next hop redundancy. This means an IP address will be shared between two equipment. One will be master, one's standby, and if the master fails, the standby equipment will take over the IP address. So this protocol is usually using multicast for advertising between both equipment with a virtual MAC address. What you have to know is with Cisco routers, if you have more than two routers in a standby group, you don't need to kill any router to take over the IP address. You just need to advertise yourself with a higher priority. And then you will have the IP address and we will get all the traffic. So this protocol supports MD5 authentication, so yeah, activate it. So here you have the command for the authentication part, and you can also define yourself the MAC address you want to use for this protocol. If you really want to add another layer of security, you could use IPsec for the communication between the two equipment. Main problem is that HSRP is using multicast frames, so it's quite tricky to set up on your equipment. But it's possible depending on your iOS release. And definitely it's only limited to two routers because you cannot have multi-point IPsec tunnels. So VRP has mainly the same issue as IPsec. Now I will go to another issue is once something is going wrong on your network, what can you do to troubleshoot it? One way of doing it is to do it locally on the equipment. So depending on the kind of equipment and the model and the volume of traffic you have on it, it may be more or less easy. Most of the time, if you have a heavy loaded equipment or switch, as soon as you will enable some debugging or traffic dump on the equipment, you will just crash it. However, it's possible. So on Cisco switches, you just have to define an ACL for the traffic you want to dump. And definitely, please activate logging buffer so the output is not directly printed on the console, but in the buffer that you can access easily. This kind of monitoring or traffic dumping will have a high CPU impact on your router, and as I said, most of the time it will crash your equipment. Another way of doing it is if you are working on router is to send the traffic you want over a GRE tunnel to another or tunnel to another device. So one easy way to do that is using a GRE tunnel, which is IP over IP encapsulation, and you can use a tool like Tunnelix on the other side to receive the traffic and analyze it. When you're on switches, it's a little bit more convenient than on a router, because you have what is called spanning tree port. So those ports allow with those ports you can mirror the traffic of your switch to these ports. You can plug your PC or any other equipment to analyze the traffic. So depending on what model of switch you are working on, you can monitor the whole switch traffic or define the VLANs you want to monitor, etc. Yeah. A nice feature you have also on 6000 series from Cisco is that you can send a span port across several switches. Let's say you have 4, 5, 6, 5, 9 on your network, you just link them, and the spanning port of mirroring port of one switch will be sent across all the switches to the last one, and you just need to plug in one place to monitor your traffic. So this feature is called AirSpan. And the nice thing is that on switches you have a performance impact which is close to zero with port mirroring. Okay, this was for the layer 2 part, so Nico will continue on with the router configuration and router forensic.
Thank you. So we're going to go ahead with some configuration basics, forensics and so on. Don't try to write everything down. We're going to put the presentation online and give you the address at the end on the last slide so you can get a copy of it. So basically, like any operating system, routers, switches and so on also have a lot of services turned on by default that nobody needs. So the first 4 tables you see are all the basic services you should turn off because they are really not useful in most of the environments you guys run routers or switches in. What is also important is to use syslog to log all the traffic to a remote workstation running syslog-d, syslog-ng, or some other kind of syslog servers. Don't forget that everything that is running on a router and logged locally on the router is lost when you boot it. It's only stored in RAM, not in flash or NVRAM. And as usual, run some NTP client on every device to get some time synchronization, and this will also help a lot to debug and have a look at the forensic side. So the slide before was basically all the global configuration commands you have to use. That ones are the ones they have to use on the interface level. So basically you have to deactivate all the things like source routing, directed broadcasts, and so on and so on. If you guys are running multicast in your network, just make sure that some routers cannot just jump in and become a rendezvous point become a rendezvous point at the multicast level so that people can try to inject new frames. And one thing that is really nice on most of the devices is to use loopbacks. Usually your routers have a lot of interfaces, each interface has an IP address, and depending on the interface that is used to send information out, like log message for example, or SNMP trap, the IP address you're going to have in the log is going to be different. So if you use a loopback and tell the box to use a loopback to do that, you will always find the same IP address or name in your logs. That also helps a lot when you have to debug. So SNMP, well, everybody dislikes SNMP but has to use it because it's the protocol that is running and that most of the people use. So V1 is the old one that everybody knows, uses SNMP communities, so to say, as a password to get access to the information. V2 had security, or something that's used to be called party by Cisco, and get bulk to get more information than just going over a set and then get next, and so on. Most of the new iOS releases support SNMP v3, so that one has integrity checking, encryption, and can even have a user defined locally on each router. So you don't have to use the same community everywhere on your network. So most of the known attacks, I mean, you guys know about it, so I'm just going to go over it quickly. The weak communities, we still see a lot of guys using public, private, the name of the device, the name of the guy, and this kind of thing. So just, yeah.
Free.
Information leak. Also, don't forget that when you guys set up an SNMP management tool, network management tool, network monitoring tool, that you have to restrict the IP space you want this SNMP community to send out. Otherwise, you're going to send information out to the whole internet. We have seen that happen sometimes. So don't give your community out. So what you can do, you have 2 options as usual when you have some things running on the Cisco devices, is use IP level filtering. That means you're going to filter out the packets as they arrive at the interface, or you can do application level filtering, that is define an access control list and use it kind of for access control at the application level. What you can also do, which is a kind of nice option on that one, is to restrict the view you're going to give the SNMP community. That means if you have some tools that just go ahead and dump the whole SNMP MIPS from your router, you can just exclude some of them so that you don't send every time, like during 10 minutes, SNMP information back. So v3 is starting to be supported by most of the devices. We have an example of how to define a user, a group, and just permit access. That one, for example, is using MD5 to do the authentication, and there's 56 to do the encryption. This is just a basic example. You guys have probably heard that SNMP had a lot of weaknesses recently. Cisco was affected by a lot of bugs in the last 2 years. One of them was the hidden ELMI community. That one is used usually in ATM networks, but was activated by default even if you don't have any ATM interfaces on your equipment. So all these SNMP bugs, especially the one that affected most of the vendors because it's in the core SNMP, that means ASN1, is always a problem. You have to run SNMP, but you have to find the right middle is running it, open, not open, and so tune it and just don't activate it by default. You also have, since recent releases of iOS, SSH support. Basically, it's the same SSH as the one from SSH.com from the 1.2.26.27 series. So this implementation by Cisco has the same bugs as the old SSH1 release, so CRC32 bug, the key recovery, traffic analysis, and so on. Bad thing, you can use or force triple DES, and you cannot use keys to authenticate on the router or on the switch. And the other downside is that you have to run an image that supports SSH, and usually they are more expensive. But you can run SSH on any Cisco router or any Cisco switch. So configuration is quite basic. You just have to define hostname, generate a RSA key for the box, and activate it. Also, since most of the 12.2 releases, you can use SCP to SCP in and out the router instead of TFTP or Telnet, which is clear text. IPsec configuration, not much to say about it. If you guys want to use IPsec instead of SSH to manage the router, you can just define the IPsec configuration. You can try to deny all traffic except IPsec, but it's not working that well and quite complex. So basically the 5 steps is to define what you're going to accept, define the security association, define IC policy, go ahead, define the transform sets. It's up to you to use tunnel or transport mode, but if you guys are running some Win2K boxes and want to use the IPsec version that's coming with Win2K to manage your router, you better go with transport mode. So you put that all together in a nice crypto map, and you affect it on the interface you want to use as the management interface, and here you go. So SSH is much more easy to set up than IPsec, but it's working too if you prefer IPsec. So going back to the router itself, you can define 2 types of things. You can have local users on the router, or you can have remote users, like with a central authentication mechanism that you're going to talk about. Basically, if you define some local users on the routers, it's using Cisco encryption type 7, which is reversible. It's just not encrypted, it's just encoded. The enable password you're going to use to go from the normal user mode to the super user root mode is using MD5, so it's not so easy to reverse or to find out. So basically what you have to define is the local users give a password to the box, and also define what kind of access you're going to give, if you want to use IPsec or going to stay with Telnet or SSH. So this is an example in the table below where you define the virtual terminals, and you say, we're going to accept SSH as incoming, and nobody can use the device itself to connect to another device. That is the transport output none. That means in that example that the router cannot be used as a stepping stone to another device. So if you don't want to go for local users on the device, you can go for some AAA mechanism. The 2 that are supported by Cisco are Radius and TACACS. Basically what is recommended is TACACS, because Radius is not that well supported and there's some limitation that you're going to quickly discuss. So you have an example of how to define the router to use the TACACS servers and with the TACACS key, and always use, as you can see, the loopback 0 to send information out. What you can do, which is nice when you use TACACS, is go for common accounting. That means that when some of your users, network administrators and so on, connect to the device, it's going to log locally all the accounting information. That means if he types show IP, BGP, neighbor, blah, 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 and so on, he's going to log that in a central log. So you can go after that and see what has been done before, a crash, meltdown, or this kind of things. All this user can be given authorization and privilege levels. By default, you have 16 levels. The default level when you connect as a user is level 1. This is kind of view-only privilege, and when you type enable and go to enable mode, which is called the privilege exec enable, you get to level 15 where you can just do anything. It's like being root, so to say, on the device. The bad thing is that you can not do that on switches. On switches you just have the two levels which are 1 and 15. On routers you can go ahead and say, okay, I want to use another level in between 1 and 15, for example level 3, and just give some command to that user that he can use. It's like being like a kind of SU do kind of thing on the Cisco device. So from that example in the table you can also see that some basic commands that are usually available in level 1, like connect, telnet, SSH, that make it possible for the guy, if you don't remove transport output, to use the router as a stepping stone, will remove these commands when he connects basically to the device. So, and as I said before, command authorization, that means asking the central AAA server for each command type if the user has the right, is only working with TACACS. That means you cannot use a basic radius server and do, okay, if that user has this right, he can use that command. This is not working. So what you can also use, and some guys, like we used to do it too in the past, was to go for Kerberos. Since Kerberos has been around like 20 years already, and since Microsoft is using it in Win2K in the core system for a lot of things, some guys just went there, tried it, and see what they can do. Most of the Cisco routers support Kerberos telnets and password authentication using Kerberos exchanges. What is cool is that in Kerberos you have this kind of name for an instance. You can basically map an instance to a group, like a group of users. And this group of users can be given a kind of privilege level. So you can say you have the network admins, the network operators, the super admin, these kind of things, and can use the Kerberos instance to do that. Bad side of the things is that Kerberos is not supported on the low-end and high-end devices, only middle range. On the Cisco switches it only works with telnets, not with SSH up to now. So two basic examples of how to configure Kerberos to do this instance mapping and use a Kerberos server with a Kerberos realm. So ACLs. ACLs are basically access control lists that can be used to filter traffic that's going into the router, coming out of the router, going over the router. That means traffic that is being forwarded. The bad side of ACLs is that on the Cisco devices, if you don't use the firewall feature set, it's not stateful and it doesn't do any reassembly. So, if you guys are using Nmap, and you can port scan by using, the right FTP data port and scan the whole internet network when the guys are allowing incoming FTP or outgoing FTP. Log input is a keyword that you can use that will also log the source interface and the source MAC address when a packet is dropped. And don't forget that since it doesn't do any reassembly, that most of the time only the first fragment is filtered. So next to that I have the different type of SEL types. The standard one that nobody uses is basically source IP address only kind of ACL. The extended supports IP address, source, destination, protocol type, ports, and also the established keyword. But since it doesn't do anything stateful, if you use the keyword established, it's only going to check if the ACK or RST bit is set. This is the only thing that's checked. It doesn't have any table database is going to look up to see if the thing is allowed. So the other kind of ACLs are the turbo ACLs that use a hash table. This is not bad because usually what happens is that for every entry in the ACL list, the router for each packet is going to process it. And if you have a lot of traffic on your network or huge ACLs, the router is going to die quite quickly. In the 72 series and up, you can use turbo ACLs. Basically, it will take all the ACs, put them together in a hash table, and you will have a constant lookup rate of 5, so to say, cycles per packet, and even if you use 1,000 entries. The other one are not that used. I'm not going to go over it, just more or less for information. So this is basically an example of how to use ACL on a router. You define the access list, and by default you say, well, I deny everything and only accept some kind of the things. We have seen that some iOS releases, if you don't put the port range, that means the 167, 67735, it's going to log the packet, but not the source port and not the destination port. This is quite strange, but we don't know why at the moment. So ACL on the switch can be used too. But not recommended, and you're going to hit a lot of problems if you start to play with LCLs on a multi-layer switch, or if your MSFC is going to be hit by all the packets that drop in this kind of things, but it can be done. So router integrity checking, we are heading towards the end. So basically 2 years back, we were trying to find a way to do some integrity checking of our configuration. Recently, like 1 year ago, Tripwire, the guys that are doing the Tripwire's file integrity checking system, came up with Tripwire-like for iOS. And basically you can do that for free with some free tools. So what we are doing is we are storing the configuration in a central CVS or any kind of central system to store files and keeping up with the revisions. So what you have to do is to use something like CVS and then find a way to get the configuration from the device. You can use a crypted telnet, you can use SSH. What you can do also, but we do not recommend it, is use SNMP. The only thing is, if you want to use SNMP to tell the box to upload the configuration to the central system, you will have to use a read-write community, which is basically bad. Once you have done that, you need to check the configuration. You can do that automatically, like every night using a cron or add job, or by writing the log files. Every time somebody changes the configuration of the router, you will see in your log files, this device has been configured by name of the guy, or when you see a router boot, or this kind of things. So there are a lot of events that you can use to do the checking. And then when that is done, well, just leave the configuration you received with the one that is stored in your CVS, for example. There are a lot of limitations, as usual with any Tripwire kind of system. You have to trust the running system on the box, like iOS or CatOS. We are just saying that there's no Cisco rootkit yet, but that's going to happen. I'm going to talk a little bit about it later on. And you have to trust the network and this kind of things. And never forget that you have two files running on the system. One is the startup configuration file and one is the running configuration file. Usually they should be the same. So, router integrity checking, like 2 years ago when we first started to discuss if it's possible to do kind of rootkit for iOS, we were just saying, is it possible? And we started to list the different points that would say yes it is, no it's not. And if you guys have attended Black Hat yesterday, well, FX came up with some nice answer, and no, we're going to tend to say yes, it's really possible to do it. Basically, iOS is a closed source OS running on MIPS for the newest models, or Motorola 16.8K. It's closed source, it's just a fork from a kind of BSD Unix. It has been affected by most of the bugs that affected other Unix systems like the zlib bug, SNMP bugs, and so on. What you can do is you can try to debug the device using remote GDB access or locally by running GDB on the device itself. While working on that, I was just looking at the book by Cisco, which is called Inside Cisco iOS Software Architecture. And what they are saying that at the kernel level, everything is running at the same privilege. That means your BGP process, your shell, everything is running at the same level. So if you can find any hole in any process running on the device, you can own the whole device. And there are not a lot of things to check if everything is doing fine. Basically, they just emphasis on making sure that the router is going to forward packets as fast as possible, not that the device is going to survive any failure of a process. And usually what happens when a process dies in the box, the router does a forced software reboot anyway. So, open questions about that. This may have been changed. I have not updated it since yesterday, so tell me if you see some wrong things. So what do we have? You don't have any local, so say, tools to play and with the device itself. It's not like a Unix or a Microsoft system. You just go, if you are missing the tool, you just upload the tool to the device and you start to play with. This is not so easy since it's running a monolithic kernel that you cannot change easily. On the switches, you have an enable engineer mode that you can go to. You have some public documents on that on the internet where you can really play with the switch itself, but since you're lacking most of the configuration files, documents describing how it's working, it's not easy to understand what's going on. What we've been thinking of is there any way to upload a modified iOS image to the box. First of all, to change it, and then secondly, is it really possible to go there and say, okay, can we do that statefully? That means upload a new iOS, run it, and kill the old one without having the router reboot. It may be possible if you use dual root processors like on the broadband concentrators, or if you just go there and try to upgrade line cards on the large GSRs, for example. There are a lot of images out there you would have to patch. Basically, Cisco has 2,500 images out there in the field and 37 feature sets. But if you would focus on an ISP, you just go there and try to modify one of the service provider release train. 1.5 years back, Cisco was working on iOS next generation that would have had support for loadable modules. That will make this kind, not to say our life, but will make the life of the attacker much more easy, but we haven't seen anything lately on that, so we don't even know if Cisco is still working on it. Okay, so last slide, talking a little bit about forensics. Basically, like I said, a router is a hardware box running an operating system. So when you have to do some forensics, I'm not going to talk about chain of custody, evidence document, these kind of things. Just give you some hints about where you should have a look at. So basically, at the top left side, it's all the things you're going to export. You should always make sure that you export the things to your syslog server. So you will have all the packets that are dropped by ACLs, dropped by unicast RPF filtering, the system informations when the interface is going to flap, if your BGP session is going to flap, configuration changes and so on. You will also, if you use SNMP, but that's going to depend if you really need to upload, so to say, upload or activate traps, you will get SNMP traps. If you guys don't use local users on the system but go for a AAA solution, you will have all the AAA logs showing when guys logged in, what they did and so on. And also what's going to happen if you activate it on the router, when the router crashes, you can have it upload automatically through FTP, I think, core dumps of the image and in the memory to see what was going wrong. What you're also going to have is all the NetFlow accounting data. NetFlow is basically a protocol that's going to count all the traffic that's flowing out the router and log it centrally to help you analyze your traffic flow. It's usually used to do traffic engineering. And what we would recommend too is to make sure that you get somewhere on some other routers copies of the routing protocol information. Routing protocol information changes quite quickly, and what you could do is run a dedicated device that's just going to be a BGP, an OSPF neighbor, for example, and from there running, for example, Zebra on a Linux box or GAD, stored all the information at least for some minutes to see what happened just before the network was down or somebody got into a router. What you need on the left-hand side till is, well, if somebody is going to boot the router over DHCP or BootP, he could just go there and make the device reboot and get the configuration and the iOS image from a remote location. That means that even if you have the iOS locally on the flash card, he could just boot the device and have it download the configuration from a remote site. So just make sure that this is not feasible and watch it somewhere. So clock synchronization is always quite important as usual. On the left-hand side, you shouldn't forget that you have basically two things running on most of the devices. That is RAM, which is volatile, and flash, that is basically non-volatile. So what you have on the flash card usually is the iOS release. That can be the one that runs in memory or a new one, and also the two configuration files. What is stored in DRAM, RAM or DRAM, depending on the hardware, is the running iOS, all the processes, the routing information, all the debugging logs, the history logs, and so on. So don't forget that basically what you see is that when somebody does forensics, you just unplugs the cable, boots the device, and see what's going on afterwards. If you do that with a router, you lose more or less everything. So don't forget that. So what is important, as said, is first of all, with a router, if you cannot get into anymore because the guy changed the password, is check your remote logs and accounting data to see if some strange activities were going on just before. There's also a nice tool that allows you to read the flashcards formatted in Cisco formats, which is available at that address. You can use it as a PCMC laptop. So always make sure that you sync before you reboot if you have done everything. That check all the local buffers, the local logs, the local information. I have some comments on the bottom to what you should have a look at. And don't forget that if you try to connect our telnet SSH to the box, you're going to make sure that the guy is going to see it. So the best thing, if you can have a local physical access to the device, is go over the console port. That's the basic thing. Also, what you can do, especially if the guy managed to block the router and so that you cannot get into it anymore by changing username, password, and so on, is if you have switches running around the router, not if you don't have a WAN-based point-to-point connection, is go there and put the switch in mirror mode and span mode and mirror all the traffic that's going into and leaving the router to see if you can find some evidence on who is connected to it and who is playing with it. So basically I have some local commands that you can type if you can get to the box. You have to have a look at the API cache, CDP neighbor information, Cisco Express forwarding information, the NetFlow accounting data, the logs, debug, the active TCP sessions, interface status. And you can also have most of that by doing a show tech support. But don't forget that if you do that, you won't have all the communities and passwords in the configuration you're going to save. So that basically was it. We're going to put the presentation online the next few days at that address. You will be able to grab the one from Black Hat that has all the information about NetFlow, DDoS detection, OSPF, BGP attacks at the same address. So just write that one down and you should get the things from there. If you see that it's not online in the next few days, just drop us an email and we're going to make sure that we put it online. Okay. I have to say, yeah, okay, give me a second.
Question d'abord.
Okay. So, do you guys have questions about that? Yeah. Come on. Yeah, if you have questions, just come over to us because too noisy with the thing behind us.
I recently was trying to use secure copy functionality. I looked in the Cisco manuals and it tells you how to get images and configs from the router to the server. But how do you do the opposite with secure copy? Say I want to upgrade the router and I don't want to use TFTP. Is there an equivalent way to make SCP upgrade a router?
Okay, SCP, basically what we know and what you have seen is that you have both client and server support on the device itself. So we have tried it and for us it's working, so maybe you just hit the bug in some iOS release.
Yeah, because I'm unfortunately it's a fairly new device. It's an access router, and they basically don't support they support the client side but not the server side. And I wondered if you know of any workarounds, or am I stuck?
No, not that we know of. Sorry.
Okay, I'm stuck. Thanks.
How much of this information applies to Cisco PICS firewalls at the same time?
Can you speak just a little loud in?
How much of this information you've given us applies to the Cisco PICS firewalls? For instance, you said that the established only checks the ACK bit.
Okay. The question is all this stateful information about stateful not being stateful. So a Cisco router by itself, if you use a normal feature set that is not the firewall feature set, won't do any stateful filtering. But the PICS firewalls, which are really firewalls, are doing real stateful filtering. So if you use the established keyword there, it's going to work.
Thank you.
In fact, what you have to know is that Cisco is using different source tree for all the equipment, like the operating system for the switches, the routers, and the firewall are totally different. So they may have the same feature, but the way they are doing it may be different.
Yeah, and don't forget that if you see the same command written the same way, it doesn't mean that it's going to be behaved in the same way if it's a router, a switch, a PICS firewall, a content switch, a local director, and this kind of thing. So you better always check the release notes and the commands, because this is something you just might hit something that's wrong. Some other questions? Okay, thank you guys.
Thank you. Okay.